Hi, my name is Faith Hurd. I'm a master's student graduating December 15th, and today I'm going to tell you about the landscape of the Sonoran Coral Snake, scientific name Microrhoides euryxanthus. Microrhoides euryxanthus, or the Sonoran Coral Snake, is a venomous snake in the family Elapidae. They are usually found in Arizona and New Mexico, but they can also be found in Mexico. Their occurrences are mainly in shrubland, grassland, farmland, and deserts. According to Frost and the IUCN Red List, they are at least concerned of becoming endangered, and they are mobile organisms who don't venture more than about 300 meters away from their burrows. The study area for this project was defined by the occurrences of M. euryxanthus. I only wanted the United States occurrences, so the Mexican occurrences were deleted. And this resulted in a two-state study area of Arizona and New Mexico. There were 300 occurrence points and 134 different land cover types. And for the occurrences, since a lot of them were close together, buffers were created about 200 meters to account for that distance, to make sure they weren't just the same organism repeated, and this resulted in 264 dissolved buffer polygons. For methods of data collection, I downloaded the occurrence points from citizen science app iNaturalist. I downloaded the land cover data from NASS Cropscape from the year 2022, and then I constricted that to Arizona and New Mexico, as you can see here in this figure. For the buffers, those 264 occurrence point buffers that I had from the last slide, I chose 5 random buffers to further analyze. And to further analyze these buffers, I plugged them into RStudio and used the landscape metrics package to analyze 7 different metrics. Diving a little further into the analysis using landscape metrics, I used 7 different metrics to analyze and quantify 3 C's of landscape, which would be connectivity, configuration, and composition. For connectivity, I used clumpy at the class level here, and I used contagion at the landscape level. For configuration, I used cohesion, which is a patch cohesion metric, and I used that as the class level. And then para-MN, which is perimeter area ratio, I used that at the landscape level. And for composition, I looked at the percentage of landscape for each class at the class level. I looked at patch richness at landscape level and Shannon diversity at landscape level. And for all of these, I used the 8 neighbor rule because M. euryxanthus can move, but they're not able to fly and get around too far. For the results here, I took the averages of the class level metrics. So we can see there's 6 different land cover types here, which I'll get a little more into in the next slide. For clumpy, or that connectivity metric, grassland and pasture had the most connectivity, whereas shrubland, interestingly enough, had the least connectivity. And from those previous buffers, we can see that they're separated by grassland and pasture and also developed landscape. For cohesion, we have a lot of aggregation of shrubland, and then for the percentage of the landscape, the highest percentage of the land cover was shrubland. Okay, for these charts over here we have the entire study area. So the entire study area had 134 land cover types, with shrubland being the highest percentage here at 69%, evergreen forest at 14%, grassland and pasture at 9%, 1% was fallow or idle cropland, and then this other 7% was all other land cover types. Across the 5 buffers, we didn't have all those 134 land cover types present. We just had this patch richness of 6 here. So we had shrubland at the highest at 73.44%, and fallow idle cropland at 5.13% at the lowest. And then all of this over here is dedicated to developed landscape. So overall, these are the landscape averages here. So a patch richness of six different land cover types represented in the buffers. For Shannon diversity, we had a pretty high level of diversity within each buffer, but I don't know if that's consistent with the entire landscape for the occurrences here. For a contagion, we had an average level of connectivity. Some of the buffers definitely showed a lot more connectivity than others, so that might be a buffer level issue there. And para-MN, perimeter area ratio, was only 0.08, which shows a low level of complexity of this landscape. So to be a little bit extra, I chose to do a species distribution model. For my climatic variables, I chose annual precipitation, mean diurnal range, which is the highest temperature minus the lowest temperature of the month, mean temperature of the wettest quarter, and annual mean temperature. And the reason I chose these four variables was to quantify the arid and semi-arid environments that the Sonoran coral snake prefers. So for this top one, they were occurring in areas of extremely low precipitation, which is expected. For here, they're occurring in higher temperatures in the wet quarters, which is when they would be out of their burrows and enjoying their time there. So that is also consistent with predictions. For annual mean temperatures, they do prefer that higher temperature of the desert, which is also consistent. This one, however, the mean diurnal range, didn't really prove to be consistent, at least for me, because they occurred in these low mean diurnal ranges, which is usually indication of a humid environment. So that was unexpected, but still nonetheless interesting. And then for the suitability model, I chose to do the generalized linear model. If time allowed, I would have done more models to compare them all. But this one did show what I expected, the suitability in those arid environments here. And then these environments over here are more grassland and pasture, but they're still in that suitability range. They're just not found as far east as we would see them. So overall, the most occurrences found from iNaturalist did occur in those shrublands and grasslands, those expected areas, and the species distribution model also showed that there was high suitability in those arid and semi-arid environments, which was also expected. So I will say there were a few caveats to this study, time being one of them. If I had more time, I would have definitely wanted to add buffers on all 264 and analyze each one of those 264 buffers in order to get a more cohesive result and see if there were any patterns I had missed by only looking at 5. And then also for the species distribution model, I would like to do some more modeling. That way I could compare and contrast different models. But that was all due to computer issues. So I hope you enjoyed this presentation and learned a little bit about the landscape of the Sonoran coral snake.